Okay, good morning everyone. So we have made this video to actually help you prepare for your N level, and today we are going to cover some basic content on waves. Then after that I'm going to go through your revision worksheets MCQ. For people who are more independent or confident in this topic, you can skip ahead, and then you can try first, and when you have difficulties then you can refer to the video. Now for structure question in the revision worksheet, we will actually leave it to the next period, and your teacher will actually go through the structure question in detail in class. Okay, so let's begin our quick recap on what is covered in the chapter on waves. So basically you need to know these few things, and that is wave will only transfer energy, and this is very important because the matter that is on the wave, it doesn't get transferred. Now what do I mean by that? For example, if I have a wave and I decided to put a toy boat on the waves, and I let this wave carry on, that means I purposely disturb the water surface, and I can do that by tapping on the water surface. The water surface will start to vibrate up and down, and if I have a toy boat resting on the water surface, it will actually just go up and down. It will not go forward, okay, as opposed to what you observe in the ocean. The object actually get blown by the wind forward. If there's no wind and there's just wave, the object will actually vibrate up and down according to the type of wave. So in physics we say that the wave will only transfer energy and it does not transfer matter. Okay, and you need to keep this in mind because many MCQ actually test you on this concept, and later on we are going to see some of these questions being asked in the revision paper. Now, knowing that waves is just a method of transferring energy and not matter, we can also classify them under two categories. Can you remember what are these two categories? One start with T, one start with L. So there are actually two types of waves. And you need to know their name. So the first type of wave is actually what we call a transverse wave. And the other type is actually called longitudinal wave. Now there are some examples that you need to remember. So for example, transverse wave is actually all your EM waves. So this covers your light, your infrared, your radio wave, so on and so forth. And of course, you will also have your water wave. So some of you are asking, how about radio wave? Well, radio wave is actually part of your EM waves spectrum. So having said that your EM wave comes under the category of transverse wave, it means that it is transverse. If you are short on memories, all you need to remember is that for your longitudinal wave, so far there's only one type, and that is your sound wave. If you need one more example for it, you can call this the slinky wave also. Remember, your teacher may have shown you a slinky. Slinky is this coil of spring, and if you do that and you push it forward and backward, it will actually send a longitudinal wave. Now having said that, well, you can also use a slinky to produce a transverse wave by vibrating it up and down. Okay, so a slinky wave, depending on the way you vibrate them, you can produce both transverse or longitudinal waves. So now you may ask, how do I decide whether or not this is transverse or longitudinal? We have to compare two directions. So let us add this condition in. Okay, so to decide whether something is transverse or whether it is longitudinal, basically we need to compare the direction of vibration versus the direction of wave travel or wave motion. The direction of wave travel, sorry. So if we know that this direction is perpendicular to each other, then we know that, oh, this wave must be transverse. Or if this wave is parallel to each other, then this wave, we call it a longitudinal wave. Okay, so basically this covers the basic concept of your wave. As you can see, it is quite short, right? So after knowing all this, there are the math part. So the mathematic part is actually quite straightforward. Okay, mathematic part, there is only two equations. First is you need to know that the speed of the wave is given by f times lambda. F stands for frequency, lambda stands for wavelength. Okay, and then you can also use this formula, the speed equals to distance divided by time. Now, what does this distance refer to? It can refer to the distance that a crest has traveled, and then the time taken, of course, is the time used for the crest to actually move from point A to point B. So you can do that. Now, most of the question involving waves, especially calculation, you need to remember that most of the time, your f is the one that stays constant. Okay? And of course, because you are going to deal with math, you also need to know what it means. So down here, we say that your f actually refers to your number of wave made in 1 second. And then you have another formula that tells you the period. So what is the period? The period basically is how much time you need to make one wave. Okay, so because of the definition, actually these two parameter, frequency and period, can have this mathematic relationship, f equals to 1 over t. Now if you look at this equation, this one and this one, you can actually combine them to form another equation, which is v equals to 1 over t times lambda. You can do that as well. So for mathematics, this is all. You only have two equations, f equals to 1 over t, v equals to f lambda, speed equals to f, distance over time you should know. And of course, you need to know how to obtain the wavelength. Basically, wavelength is just the distance between two crests. And then you need to know what is the meaning of frequency and period. Frequency is just how many wave is made in 1 second. So if I say the frequency is 10 hertz, all it means is that the wave will produce 10 complete wave in 1 second. Okay, so the hertz simply means that how many wave in 1 second. And if I tell you that, oh, the period of the wave is 2 seconds, what does it mean? Well, it means that in order to make one complete wave, I need 2 seconds. So how much time do I need to make two wave? 4, 2 times 2. Okay, so that is it. And one last thing about your waves is that it can be represented by graphs. So there are two types of graphs. One is called the distance position graph. So sometimes the question will actually change the naming of the x-axis. They can call it displacement, they can call it distance, and so on and so forth. But as long as you can see that the unit for your x-axis is meter, mm, cm, this kind of thing, you know that it is a distance position graph or displacement position graph. So down here, you can also call it displacement. I think it is better to call it displacement because distance only involves positive number, but displacement, you can have the negative region also. So basically, you see this A, it refers to amplitude. So sometimes the graph will look like that, and then you are supposed to read something out of it. Just remember, the displacement position graph, one wave form, this is called waveform, one of it will give you one wave length. So for example, if down here I tell you that this is 0.5 meter, what is the wavelength? Or it means that your lambda is actually equals to 0.5 meter. Okay. The second type of graph is actually called the displacement time graph. Okay, so the displacement time graph, if you have one waveform and then they tell you that, oh, down here it is maybe 3, then what it means is that the time taken to have one wave, so one wave, the time taken for one wave is 3. And what does that mean? One wave is produced, right? This red color highlighted line, this one, this red one, right, is one complete wave, right? So one complete wave produced, it takes 3 seconds, right? So that is your definition for period. So this one is telling you that the period of this wave is 3 seconds, and you can actually use this to find out that, oh, my frequency is 1/3 Hertz. Simple as that. So basically the graphs, these two types of graphs will give you different information that you will need to actually find out more for your graph. Most of the time, these two information, it is going to be used in your V equals to lambda formula. Okay, so basically you can see that the wave chapter is actually quite short. I just need 2 pages and I can finish my notes already. So this is how these are the content knowledge that you will need.